Okay, our next unit is on momentum, impulse, and collisions. And so let's first say, what is momentum? Well, momentum is a word we use to describe mass in motion. And if you look at this animation, there's a truck and a car. The truck is moving at first, the car is not at first. And then after they collide, both are moving. So when something is moving, it has momentum because it has mass and velocity. But at the beginning, this car is not moving. Here, it's not moving, so it has no momentum. But after the truck hits it, it begins to move, so then it does have momentum. A non-moving object cannot have momentum because it has no velocity. Momentum there's an equation for it, so it's a quantity that has an actual number. And the equation is up here. Momentum is equal to mass times velocity. We know mass and velocity. Momentum is simply just the product of mass and velocity. And for some reason, scientists have chosen the letter P to represent momentum. The unit of momentum is the same as the unit of mass, kilograms, times the unit of velocity, meters per second. So that makes the unit of momentum kilograms, meters per second. So if you look at the animation again, and you look at this table, you have the truck, which has a mass of 3,000. Its velocity is initially 20. Multiply that together, you get 60,000. And that's before they collide, and these numbers are changing because after the collision, if you watch the truck, it slows down. Its mass doesn't change, but it does slow down, and as it slows down, it gets less momentum. So if you watch these numbers here, that bottom number is always that number times that number. Okay, and the same thing with the car, except initially the car is not moving, so at the beginning its momentum is 0 because its velocity is 0. But then afterward it does have velocity, but still the mass times the velocity is equal to the momentum. Okay, so just as a practical kind of question, if you have a baseball and dump truck, which has more momentum? Well, it does depend on how fast they're going. A baseball thrown 90 miles an hour, it does have momentum because it has mass and velocity. But compare that to the momentum of a dump truck, which is going slower, only 35 miles an hour, but you know that the dump truck is much heavier. So in fact, this one, the dump truck is going to have more momentum than the baseball. And momentum is a vector, and if you recall, a vector is some quantity that has both a magnitude and a direction. It has a how much, and it also has a in what direction. So, and it turns out that the direction of the momentum is determined by the direction of the velocity. So in the animations of that truck moving across, the momentum is to the right because the velocity is to the right. So we can have positive momentum to the right and we can have negative momentum to the left. In this example, they're showing how if you change the mass of something, that's going to change the momentum. Okay? And that's simply because of conservation of momentum. So in this slide, what we see is a car moving across. It has a load of bricks, and then all of a sudden it has another load of bricks, and it slows down. It slows down when it gets that load of bricks, and you would expect that. You would expect that the more mass it was given, it would slow down, and that's in fact what happens. And the reason why is because the momentum of both the car and the bricks, the total momentum has to stay constant. All right. So this is a bunch of equations, a slide that has a lot of equations that show the importance of a quantity we're going to learn about called impulse. This top equation here is the original equation that we had a few slides back. Momentum equals mass times velocity. These triangles are thrown in there. Those are delta, which stands for the change. So the change in momentum is equal to the mass times the change in velocity. So when the velocity changes, the momentum changes. Momentum changes with velocity. Now this equation should look familiar because we've used it in the past, maybe 2 units ago, when we were talking about linear motion. So acceleration is the change in velocity over time. That's the definition of acceleration. Acceleration is the change in velocity. And then this next one you should recognize, the force is equal to the mass times the acceleration. This is one of Newton's law, Newton's second law. You should know that. And it says that acceleration is caused by force. So momentum changes with velocity. If you change the velocity, you're going to change the momentum. But velocity changing is acceleration. And acceleration is caused by force. So if you take these 3 equations here and kind of combine them together, what it shows is that force, what we did was algebraically combine the equations together, especially this equation here and Newton's second law, that one there. If you combine those two together, F equals ma, substitute, instead of a in this equation, put delta V over t. So F becomes F, this equation becomes F equals m times, instead of a, delta V over t. That's what we have down here, F equals m delta V over t. Well, because delta V over, then you take this equation here and rearrange it, multiply both sides by t, you get Ft equals m times delta V. So the whole part of this is showing how m times delta V is equal to the force times the time. So mass times change of velocity is the change in momentum, and what causes that is force. So the ultimate outcome of all these equations here is that force causes momentum to change.